So we've been talking about deduction since spring break, really. We've been talking about an approach to deduction through propositional language, a very specific sort of approach, a very specific sort of formal language that we're using to handle complex statements so that we can determine whether or not arguments that we make with those complex statements are valid. And we've also found that we can do all kinds of other things with the tools that we're developing for this as well. Now, we've looked at the truth table method in order to kind of approach propositional logic issues. What's your feeling on the truth table method? Good method? Do you feel like have you mastered it more or less? Feeling comfortable with the truth table method? What's your biggest gripe about the truth table method? When they get really, really big, they're very, very complex. If you mess up one thing, the whole thing goes kablooey. That's probably true of like most sorts of deductions, but we're particularly susceptible with truth tables because they can be so complex, right? When they get really, really complex, if you're not super duper tidy in the way that you make your truth table, you can make mistakes. It's, as I've mentioned before, this is a type of strategy that works really, really well for computers. I don't know if it works so well for humans. It seems like, at the very least, it's not the way that our minds, what's the word I'm looking for? Maybe naturally. The way that our minds naturally work. On the other hand, we have a new method that we're introducing today called natural deduction, which you might suspect does match the way that our minds naturally work a little closer. This is a method that, when mastered, is much, much easier to use than the truth table method. We don't get the same sorts of problems that we encounter with truth tables when they get really, really complex. So one of the things that we're going to be able to do with this natural deduction method is we're going to be able to handle arguments that have lots and lots of terms. The truth tables for which would be enormous, right? We'd be getting up to like 16, 32, like 64-line truth tables, which are just bananas to do by hand on paper. If we could have another route to figuring out whether or not an argument is deductively valid, it would be a valuable one. And that's what we're working on today. So, just to kind of get us started, let's say that we want to prove a certain conclusion from a collection of premises, but it's not immediately clear how. And for one reason or another, a truth table would be incredibly inconvenient to use. We've discussed possible reasons why. One of the most obvious sorts of reasons why a truth table would be inconvenient is if it would end up being really, really big. So what do we do then? Well, the basic idea, and it's a really simple, straightforward idea behind natural deduction, is that if I can make a series of discrete steps from my premises to my conclusion, and each of those steps is one that I know is deductively valid. So like step 1, that's a valid step. It doesn't get me to my conclusion, but it gets me to some intermediary between my premises and my conclusion. I'll take another step. That one's valid too. Doesn't quite get me to my conclusion, but it gets me to another intermediary. If I can make a whole bunch of little steps, and every single one of those steps is a valid one, then the whole series of steps is also going to be valid. Does that make sense? This is kind of a big part of how validity works. If I can make a valid inference from my premises to some conclusion, not the conclusion that I'm looking for, but some conclusion, and then I can use that conclusion as another premise to make more valid steps. When I string all those steps together, if every single step was valid, then the whole series is going to be valid. Yes, Josh? What do you mean? Instead of the truth table method, you can conceivably use this entirely in place of the truth table method, but we might find there are going to be some limitations to this method as well. One of the things that we'll learn as we kind of develop more and more skills with natural deduction is we're limited by the sorts of steps that we have available. So there are more valid steps than maybe I can remember rules in my head, or even that I might be able to collect. What we're going to be doing is we're going to be building up a whole library of little steps that we're like, I know that step's valid, I've seen that before. Each of those steps is valid. So as long as we have a bunch of steps that we know, I'm going to be able to determine whether or not an argument is valid. But if I don't have those steps, that doesn't mean the argument isn't valid, it just means that I don't know how to get from my premises to my conclusion just yet. A truth table would be able to settle that matter for me. The other thing that we'll probably encounter, maybe not today, but as we build up more and more things in our library for natural deduction, more and more rules or steps that we know that we're allowed to validly use, we might encounter that it's not just the limitation of the sorts of steps that we have available to us. There's a little bit of, how do I want to say this? It requires a little bit of imagination in order to see the path from your premises to your conclusion. And sometimes it just ain't happening. Even with the best of us. I was talking with Professor Bottenberg, who teaches our upper division, 310, formal logic class, and we were both commenting on, like, sometimes, like, even she and I, who, like, know this stuff pretty well, sometimes we're looking at a proof and it's just, like, it just doesn't jump out at us. So this can be the sort of thing that's difficult. You might have encountered this in mathematics, too, that sometimes your professor will be like, oh, so we see that this equation simplifies to this other equation, and you're like, how did you know to do that? And they're like, you just see what the equation needs, and you do it to the equation so that it becomes, like, more easily soluble. And you're like, how do you know? And they're like, well, they're experts, right? So they just know the way that a lot of expertise works. And so it's a difficult thing to teach, but you know, if we do it like little bit by bit, we can kind of learn the ropes. Yeah, Olivia. What do you use this for? You use this for determining whether or not you can derive valid conclusions from a set of premises. What's the practical use of determining whether or not you have a valid conclusion from premises? It tells you whether or not somebody who believes the premises needs to also believe a conclusion. And this is useful in all kinds of discussions and disputes that you have with other people. It's useful in kind of guiding your own thought. If you say, I believe A, B, C, and D, what else am I committed to by believing A, B, C, and D? This will help us determine that. It kind of guides the way that our thought progresses from believing one thing, or a collection of things, to believing new, different things. Does that answer your question? Maybe a little late in the semester to be wondering, like, what's the use of all this stuff? Like, it's useful for thinking clearly, whether we're doing it by ourselves or with others. Okay, so this is the basic idea behind natural deduction. We're breaking up our progression from premises to conclusion into a bunch of discrete steps, each of which needs to be valid. So, the way that we do this is we build up a library of valid steps, things that we know, like every time I do this, it's going to be okay. We're going to start with 4 of them today, 4 steps. With every class that we have available to us from here to the end of the semester, we're just going to add some more things to our library. So we'll do 4 today. The next time we meet and talk about natural deduction, we'll add 4 more. Then we'll add 4 more. We could conceivably do that, not forever, but for at least a semester. We could just like add new rule, new rule, new rule. The ones that we're going to start with today are fairly familiar. We've seen these before. We saw these at the beginning of the semester. They are Modus Ponens, Modus Tollens, Disjunctive Syllogism, and Hypothetical Syllogism. We remember all of these, do we? I remember them. Do you remember them? They're at least vaguely familiar, some of them. Just in case anybody was wondering whether or not these are actually valid, and you're not necessarily just taking my word on it from the beginning of the semester, we can do a truth table to determine whether or not a Modus Ponens argument is valid. So look at it like this. Modus Ponens is always this thing. It's always if P then Q, P therefore Q. So if I want to determine whether or not that inference from if P then Q and P to therefore Q, if I want to know whether or not that's valid, I just can use my truth table method. It's fairly straightforward for this little step that only has 2 different terms in it, P and Q. So I'll have a nice 4-line truth table that shows me that here's premise 1, here's premise 2, here's my conclusion. Whenever premise 1 and premise 2 are true, my conclusion also has to be true. There are no lines on this truth table where all of my premises are true and my conclusion is false. Therefore, Modus Ponens is valid every single time. Cool? That's our old friend Modus Ponens. Modus Tollens was a little harder, if I recall correctly, from like what happened earlier in the semester. Modus Tollens is kind of like an inside-out Modus Ponens. It takes us from if P then Q and not Q, which is our second premise. So we deny the consequent. We say no to Q, and that allows us to then deny the antecedent, to say no to P. And again, if we're curious whether or not that's actually valid, and we might be a little more curious about this one than Modus Ponens, because it's not so obvious on its surface that this is a valid inference, we can just do another truth table. And again, it's going to be a pretty straightforward four-liner. I only have two terms, P and Q, and we'll notice that there are no lines on this truth table where all of my premises are true, and my conclusion's still false, which is to say, whenever my premises are true, my conclusion also has to be true. Therefore, it's valid. That's Modus Tollens. We also had the old disjunctive syllogism, which starts me off with a disjunction, with an A or B, or in this case a P or Q premise, and then denies one of those two disjuncts, and says no to P. We could also just as easily say no to Q on this, and it would work out just fine. If I say no to one of my disjuncts, that means that the other disjunct has to be the case. So P or Q, not P, therefore Q. And that's valid every single time. And if you're not sure about that, if you doubt it, we can make a truth table. And again, it's a pretty straightforward four-liner, because we only have two terms in this, P and Q. Last but not least, for today at least, hypothetical syllogism. Hypothetical syllogism is if P then Q, if Q then R, therefore if P then R. This is the eliminate the middleman move, right? I have two conditional statements. I'll notice that the consequent of one is the antecedent of the other. And that tells me that, like, oh, if P then Q, and if Q then R, just forget about the Q middle step and go from P to R. That'll work fine as well. And because this one has P, Q, and R, its truth table is a little bigger. It's an 8-liner. But the principle is still exactly the same. We'll notice that there are no lines on this truth table where all of my premises are true and my conclusion's still false. And another way of saying that is, if the premises are true, the conclusion has to be true, and that's a valid inference. 4 rules. Each of them is a valid step, so I can use them in series to make bigger, more complex valid inferences. For example, let's say I have an argument like this. If Aaron gets the job, then Ben won't get the job. If Carol gives him a good job, if Carol gives him a good job recommendation, then Ben will get the job. Aaron does get the job, therefore Carol did not give Ben a good recommendation. And I might be thinking to myself, like, is that valid? Maybe it's valid? Is anybody thinking through it right now, trying to figure out, like, is that thing valid? What do you think? Is it valid? I see some yeses, some nos. Let's prove it. Let's work it out. Instead of trying to do it all in our head, where things get lost in the shuffle, or where we might have a hard time trying to convince others who disagree with us whether or not that argument would be valid, let's formalize it first. I have if Aaron gets the job, then Ben won't get the job. If Carol gives him a good recommendation, then Ben will get the job. Aaron does get the job. So 3 premises that I'm beginning with here, right? 3 premises, and then therefore, my conclusion that I'm trying to draw from this is Carol did not give Ben a good recommendation. And the way that I'll set this up for natural deduction is I list each of my premises. First, I formalize them. I put them in my formal language. So if Aaron gets the job, then Ben won't get the job. If A, then not B. Why not, right? Where B is Ben gets the job, A is Aaron gets the job. If Carol gives him a good recommendation, so Carol gives him a good recommendation to C, then Ben will get the job. Aaron does get the job. Therefore, Carol does not give him a good recommendation. And notice the way that I'm setting this up is in separate lines instead of kind of putting them horizontally, the way that I did with the truth tables. Now I'm just kind of listing them one at a time. And the conclusion that I'm trying to get to, I'll put after my last premise, off to the side, just to kind of place it there and remind me, like, that's what I'm going after. I have line 1, line 2, and line 3, and I number each of these lines. This is important as well. We'll see why in just a moment. I'll number each of those lines, and then off to the side, I'll note, this is the thing that I'm trying to prove. This is the conclusion that we're trying to draw. And the question is, pardon me, you ever choke on your own saliva? That's gross. So the question is, can I get from these to this with a whole series of valid steps? And we only have these 4 valid steps available to us right now. Modus Ponens, Modus Tollens, Hypothetical Syllogism, and Disjunctive Syllogism. You remember them all? It's just those 4. All right. So, which of those 4 steps can I actually use? This is maybe a good place to start. What can I do? If I'm starting with if A, then not B, if C, then B, and A, Are there any things that jump out at me as kind of like, oh, I can use this rule right here? Forget about like trying to steer your way to the conclusion. First, let's just try to move forward from where we are. Yeah, Sean.
Maybe the fact that there's 3 different propositions.
We have 3 different propositions.
Well, yeah.
Yes, that's true. 3 premises, right?
Yeah, 3 premises. So basically, like a hypothetical syllogism.
Of a hypothetical syllogism that goes from if one thing, then another thing, if A, then B, if B, then C, then if A, then C. And hypothetical syllogism only works when that middleman, that middle term, is the consequent of one conditional statement, and it's the antecedent of another conditional statement. Do I have that set up for me? I have 2 if-then statements, but I'll notice I don't have that matchup that I'm looking for in a hypothetical syllogism where the consequent of one is the antecedent of another. So maybe this is helpful. By elimination, I'll notice like I can't do a hypothetical syllogism right now. Can I do a disjunctive syllogism right now? What do I need for a disjunctive syllogism? I need a disjunction, right? I need an or statement. Do I have any? Nope. So process elimination, take that one off the list too. Can I do a modus ponens or a modus tollens? Yeah, James. I can do a modus ponens. What can I do a modus ponens with? And let's start a good habit here. Direct me to the lines that I would invoke in order to use modus ponens. Modus ponens. So I'd use modus ponens with lines 1 and 3. Yeah. Line 1 says if A then not B. Line 3 says A. So if A then not B, and A, therefore, not B. Modus ponens allows me to do that. I'll use MP for modus ponens, MT for modus tollens, HS for hypothetical syllogism, DES for disjunctive syllogism. And note that I'm citing the lines and the rule that I use in order to derive this new line. So now I've drawn a conclusion from the premises that I have, and that conclusion can now act as an additional premise going forward. Does that make sense? As long as those premises are validly derived from the premises that I started with. So as long as every single line after this last premise, right? After my prove line, where I tell you what my conclusion is going to be, every single line after this has to have some sort of justification for why I'm allowed to say it. So I'll say not B. Why am I allowed to say that? Well, lines 1 and 3 and the rule modus ponens allows me to say not B. Now what? I can use not B to be modus tollens with what? So line 2 and line 3 and the rule modus tollens is going to allow us to conclude what now? Not C, right? So if C, then B. Not B, therefore not C is how modus tollens works. So not C, and why do I get to say that? Because of lines 2 and line 4 and the rule modus tollens. And hey, how about that? Not C. That's what I was looking for. That's the conclusion that I'm trying to draw. And I made it in a series of valid steps. Only 2 valid steps. This is a pretty straightforward natural deduction. So what does this tell me? This tells me that that conclusion can be validly drawn from those premises. The argument given in natural language up above is, in fact, a valid argument. Decent exposition of the principle? We all get how this works? Of course, it gets a little more complicated when it gets a little more complicated, right? When the proofs are a little bit more complicated, or are more complex. So let's start from this. Let's dispense with the natural language stuff just because we know how to translate from natural language into our propositional language. Let's just cut right to the chase. I want to prove conclusion T from these 3 premises. F or if D then T, not F and D. Can I do it? Can I prove T validly from those premises? Well, I set myself up, premise, premise, premise. This is what I'm trying to prove. And then I try to see, can I get from those premises to this conclusion in a series of valid steps? What should I do? You guys tell me. Lead me through this. And what can I do? What are the things that I notice about this? Do I have a whole bunch of if-then statements? Do I have multiple if-then statements that I can maybe do hypotheticals? No, I can't do a hypothetical syllogism. I'll notice that I've got an or statement. Or statements are useful for disjunctive syllogisms. Can we do a disjunctive syllogism? Yeah, I can. Line 1 and line 2. Line 1 says F or some other thing. Line 2 says not F, so that means I can validly conclude the some other thing. Yeah, if D, then T. If D, then T, and my justification is line 1 and line 2, and the rule disjunctive syllogism. What's next? Am I there? Not quite. If D, then T isn't what I'm trying to prove. I'm trying to prove T. But I have if D, then T. How can I get from if D, then T to T? If I have D, and I do, right? So modus ponens with which lines? Yeah, 3 and 4. You might do, I have a tendency to do, like, say it 4 and 3, just so that I can remember that it's in exactly that modus ponens form. First, the conditional statement, then the antecedent, therefore, then the consequent. So yeah, 4, 3 modus ponens gets me T, and hey, how about that? T was what I was trying to prove. So can I validly prove conclusion T from those premises? Yes, I can, and there it is. That's what the proof looks like. And you get a sense of why they call this natural deduction? This kind of like, it's this stepwise process in which you take what you know to get something else, and then that something else becomes now something that you know, and you can use that to feed it back into the loop of trying to derive more inferences. This, for my part, this feels a lot closer to how my mind already works when I'm thinking through some sort of complex inference. Questions about this? Let's try one more together before we dive into the worksheet. So here I have 4 premises. 4 premises. If C then M, then if C then M, then if R then P. If C then R, then if R then M. If C then P, then not M. And if C then R. Those are my premises. And I want to know, can I validly conclude not C from this mess? And maybe you're smarter than I am, but I can't tell at a glance whether or not that's valid. I'm going to have to break this up into smaller chunks. So if you're kind of blessed with foresight, or if you have a lot of experience with natural deduction, you might already be able to see a path. One strategy that I recommend is like maybe try to think backwards. Know that you're eventually trying to get to not C, and then look around and see to yourself, like, how would I even go about trying to get not C? Maybe I could get not C if I had not R, and then I could do Modus Tollens. Line 4 and not R would get me not C. So then maybe I'm on the lookout for not R. Yeah, maybe. But how would I get not R? I can't really see how to work it backwards. Maybe I just start with what I have, and again, not necessarily thinking about how to get to my conclusion, but just how do I move forward? How do I get something else, something new? So what do you see? What can you do? Yeah, Gordon. So line 2 and what else? And 4, and what rule? Yeah, line 2 and line 4 with modus ponens will get me what? It'll get me R? Yeah, let's see. Line 2 says if C then R, then if R then M. Line 4 says if C then R. So I've got the antecedent, if C then R, and that'll get me the consequent, if R then M. So the inference that I can make from here is to if R then M, and the justification is lines 2 and lines 4 modus ponens. Let's see if that was actually the first step that yeah, that was. Okay, good. You're doing it in the same order as I am. And I don't, like, have you already started to anticipate that you can do these steps in multiple different orders? So your natural language proof might not look exactly like your neighbor's, although it may very well have the same steps. All right, so now I have if R then M. What else? I've got something new. Does that help me out? Yes, Stephanie. Therefore not M, yep. What rule would you use for this? And this is one of the reasons why maybe it's good to be limited by like rules that you already know are valid, because otherwise you can start to like spin all sorts of like, oh, I think I see how this works, but if you're trying to work it out in your head, things get lost in the shuffle, right? So there seems to be something going on with that. I agree with you that if C then R, then R then M, if R then M, all right, I've got that. I've got if R then M. I know that maybe I could end up with something like, ooh, not M would get me to not R, and then not R would get me to not C. What else do I have going on here? I'll give you a hint. Look at lines 4 and 5. Ooh, there it is. It just jumped, right? Like a magic eye painting. Yeah. So what can I do with lines 4 and lines 5? Yeah, if C then R, and if R then M, so if C then M, right? By hypothetical syllogism, lines 4 and 5. Now what? This with line 1, right? Yeah, line 6 and line 1, or line 1 and line 6 will get me what? If R then P by 1, 6 modus ponens. So now I've got if R then P. Anything else? Gordon? 4 and 7, I can do a hypothetical syllogism that'll get me if C then P. You guys are thinking through it just like I did. Now what? What about line 3? Line 3 and line 8 will get me not M by modus ponens. Oh, I can taste it. I can taste it. It's so close. Can not M get me to my conclusion? Yeah, not C by line 6 and line 9, modus tollens. Modus tollens, 6, 9, modus tollens gets me not C, and boom, not C was what I was out to prove in the first place. This is valid. Bless you. For your sake, at least for now, as we're getting warmed up on this, they're always going to be valid. If I ask you to prove something, you can rest assured that there is a valid proof that can be done with the rules that you have available to you. This is maybe another one of the shortcomings of the natural deduction method is that, like, if you can't find a path, does that mean that the argument is invalid? No, it just means, like, you haven't found the route yet. So just because you can't figure it out doesn't mean that it's not invalid. If you can figure it out, though, and if every step is a valid one, then the entire series of the steps, everything, like the inference from the premises to the conclusion, would in fact be valid. And if you're ever in doubt about this, if you're ever looking at that and thinking to yourself like, yeah, it looks like it works, but I'm just not feeling confident about natural deduction, what can you do to check your work? You can make a truth table. That'd be a doozy. There's a lot of terms on this. C, M, R, P. Yeah, that's going to be 2 to the 4. 16 lines. That's big. That's around the boundary for what I would reasonably try to tackle. How you feeling about this? Ready to tackle a worksheet? All right. Sounds good. Worksheet. Does everybody have one, by the way? Some folks came in late. I'll make sure you guys get one. And let's start with the front at least, 1 through 4. Work on those by yourself / with your neighbors. And we'll check in on 1 through 4 and see how everybody's doing. If we have more time, we can get to the back of the worksheet as well.